Hey guys, I'm Jade. Today is my LeetCode review vlog on the 117th problem, populating next right pointers in each node, second edition. We are given a binary tree. We have to populate each next pointer to point to its next right node. If there's no next right node, the next pointer should be set to null. Initially, all next pointers are set to null. And after the modification, we'll return the root node of the binary tree. Then, let's see the example 1 here to understand this problem easily. We got the input binary tree here, and we have to make the node 2 points to node 3, and node 4 points to node 5, and node 5 points to node 7. And we'll return the root node, which is node 1 of the binary tree. Then, let's get started with our introduction to solve the problem. And the keyword is using already established next pointers. Using already established next pointers. And the detail tip is we'll use the next pointers to traverse the current level and establish the next pointer for the next level at the same time. Then, let's get started with our code and detailed annotations to solve the problem. In the first state, we have to check for one edge case. If root equals null, we just return null, as the tree is empty, so we don't have to do anything. The second state, we'll create a current variable to help us solve the problem. And we should initialize the current variable to the root node to start the level order traversal, and also for each traversal of each level. Node current and start it at root. Next, we also have to create a dummy node to mark the start of each next level, as the dummy node would point to the start node of each next level during the iteration. And code is node dummy equals new node of 0. Next, we also have to create a previous variable, and we have to initialize the previous variable to dummy. And the previous variable is used to build the next connections for the next level. And code is node previous started at dummy. Then we have to create a nested while loop to continue the iteration. And code is, and the outer while loop is while current is not equal to null, which means there are remaining levels to process. And inside the first while loop, we also have to create a nested while loop, the inner while loop, and the condition is the same, while current is not equal to null, and we'll continue this inner while loop. But the second condition is very different. If the current is not null, which means there is still remaining nodes to be processed. And inside the second inner while loop, first, we have to check if the current node has a left child. If so, we'll connect the previous .next pointer to this child. If current .left is not equal to null, then we have to connect them. And code is previous .next equals current .left. And there's one thing we have to notice. if the previous pointer is exactly dummy node, which means the dummy.next pointer would be updated to point into the start node of the next level. And this feature is very useful. Second, we also have to move the previous pointer one step forward to the newly connected node previous.next. Previous equals previous.next. Second, we also have to check if the current node has a right child. If so, we also have to connect them. If current.right is not equal to null, then we have to connect the previous.next to current.right. Previous.next equals current.right. And we also have to notice the same thing. If the previous pointer exactly pointing to the dummy node, then dummy.next pointer would be updated to point to the start node of the next level. And the second step, we also have to move the previous pointer one step forward. Previous equals previous.next. Then we have to move the current pointer to the next node in the current level. This is because we have assigned every next pointer in the last outer iteration. But if the current node is the root node, it doesn't matter because the root node must not have its next node. The next node of the root node must be null, so we don't have to worry about it. And code is current equals current next. And out of the inner while loop, which means we have finished the current level and we have traversed all nodes in this level, then we have to move the current node to the first node of the next level. And the code is dummy.next. Code is current equals dummy.next. The reason that why the first node of the next level is dummy.next is because we made the dummy.next pointer point into the start node of the next level in the code above, which is the two things we have to notice before. Next, we also have to reset the dummy.next pointer to null to prepare for building connections in the next traversal. And if we don't reset dummy.next to null, an infinite loop could happen. This is because in the final outer iteration, dummy.next won't be assigned to the null because the current node won't have any left or right child node. So the dummy.next won't be assigned to any new node or null. And we also have to update the current node to dummy.next again, which would cause the infinite loop. So this code is very, very useful. Dummy.next should be reset to null. And the final step, we also have to reset the previous pointer to the dummy node to start building the next level's connection. Previous equals dummy node. And out of the outer while loop, which means we have finished the traversal and connection process. So we just return the root of this modified subtree. Return root. And let's submit the code and check for the correctness and analyze. Oops, I tapped something wrong here. Let's revise it and resubmit it again. Then Let's analyze the time and space complexity. Yes, our code got accepted. The time complexity, it is big O of n, and n stands for the number of nodes in the binary tree. As we have traversed each node in the binary tree for only one time. And the space complexity, it is big O of 1, as there is no additional space related to the number of nodes is used. We only create several variables, for example, the dummy pointer, dummy node, previous pointer, or the current pointer, which are constant extra spaces. And this is the end of my LeetCode review vlog on this problem. And I highly recommend you guys to visit my online GitHub page here, which contains all the nodes for the top 150 LeetCode problems. For each LeetCode problem, you can see problem description, intuition, Java code with annotations, and the final time and space complexity analysis. You can also visit my GitHub repository here, which contains all the codes and nodes to build this online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for your watching. I'll see you next time. Bye bye.